Alright, welcome back. So in my last video I covered classes, and this is just basically a continuation of that. So if you have already walked through the classes video with me, just open it right back up because we'll be using a lot of stuff that's already in here, unless you like typing. Or if you want it to all break, yeah. Make sure you have the other one open and just add on to it. So in my last video I covered classes, a little bit about object-oriented programming. We covered the syntax of classes. We created our first class. And we added some properties. We added some computed properties. We did an initialization of our properties, and then we created a method. Yeah, a method. Awesome. Alright, and then we have some instances of said class. So, this is just basically a continuation of it. In this video, I'm actually going to cover subclasses or inheritance. So, basically what inheritance is, it's a fundamental behavior that differentiates classes from other types, like structures in Swift. So basically, you can create a class that inherits from another class to create something new, basically. So in this video, I'll be covering subclass syntax. We are going to create a class, basically a circle class based off of our shape class up here that we've already created. And then I'm going to introduce a couple of things like overriding. I'm going to cover overriding, extending our circle class beyond what it inherited from the shape class, and then we're going to create an instance of our new class, our new subclass. Alright, so let's go ahead and get started. So the syntax of a shape class is basically, or the syntax of a subclass is kind of like a regular class. So you type in the class keyword, you give it some name, so we're going to say some subclass, because that's its name, and then we do colon, and then we bring in the name that we're going to use. So in this case, I'm going to do shape. Basically, the reason why I'm doing this is because I don't want it to error out on me. But basically, it's going to be some random name. Okay. Actually, I'll just go ahead and do some base class. Or it could just be some class. Okay, and then we have properties in here. You could have methods, and etc. So you can have a lot of stuff in here. Okay, so that is our syntax for a subclass. I'm thinking this is probably not airing out because I created the syntax up here. I did. So here we go. Here's our class, some class, which actually is considered a base class in our example. So this is the base class, and then our subclass inherits from our some class from above. Okay. All right. So that is the basic syntax of creating a subclass. It's not really that hard. Just add the colon and then the base class name. All right. So let's go ahead and create one. All right. Sorry, I duplicated my notes for some reason. Alright, so let's create a new class. So this class I'm going to name Circle, and its base class is going to be our shape class from above. So we add our curly brackets. Alright, so the first thing basically what this has done is it's kind of created a virtual copy or reference to the shape class. So this circle class has access, or has inherited everything inside the shape class. So everything that we've written out here, all these properties, this initialization, and this method. So it's inherited all of that. So we don't have to type this stuff again for this subclass because it's already inherited it. So now we can add more stuff to it that is of particular importance to Circle class. Plus, we can also modify what it's actually inherited. So the first thing I want to do is I want to bring in a new variable called radius, because when we do any calculations with circles, we don't go by width, we don't go by length, we don't go by height, we go by radius, we go by diameter. So in this case, I want to actually create a method here that will be the radius. And so I'm going to make this a CG float. Oh, quick point. I did do an update to this. So go back into the shape class and you see this width here, because I'm actually going to use width to create the information for the radius. So for width, change it from an integer to a CG float. So if you just copy that, make it into a CG float. I think I also did the same with X and Y here. But I think it only gets used once, which is in the point section. So make sure you update area, make sure that's CG float, update width here in the initialization to CG float, and also update calculate parameter with a CG float as well. I realized I made a kind of a boo-boo when I was creating the notes for subclasses. So quick hint. Update all this, otherwise you get wonderful, beautiful errors, okay? So, back to radius. So var radius, and it's going to be CG float, because what I wanted to do is I wanted to actually calculate this information from something that it's already inherited from, which is width. So I'm going to do dot self width divided by 2, because width is basically diameter. It's the width of a friggin' circle, right? Okay, and now we get this wonderful error. Why do we get this error? Well, let's find out. It says use of unresolved identifier self. Why did it give us this error? Well, it's kind of a obtuse error message. It doesn't really give us much information. We're like, well, it technically should work, right? Well, the reason why it doesn't work is because, first of all, the compiler is trying to calculate this right now. And the reason why it can't and why it's thrown this error is because width, or this class doesn't have an instance. So if you remember width, if we look up here, we see that width has to be initialized before it's used, right? So that's why this is throwing an error, okay? But we need this. We need this to calculate stuff, right? So how do we get around that? Well, you use the keyword lazy. Yes. So basically what lazy is, I'll just type it out. So lazy, the lazy keyword, denotes a stored property whose initial value is not calculated until it's first used. So a stored property whose initial value isn't calculated. Oopsie, sorry about that. Isn't calculated until it's first used. Okay, so basically what it does is it doesn't immediately calculate it. It just says, okay, well, when it's first used, then it's calculated. If you notice, our wonderful error message went away. So that's a lazy that's a lazy stored property. So you got a bonus there because I didn't mention that, but that's how you fix that issue. Because I do want it to use something that's already there. I don't want to create, initialization for radius. I want to use something that I know it's already inherited from shape, which is width. Okay? Alright, so we have the radius. Now the next thing I want to do is I want to do some overriding. And what is overriding? Well, overriding allows you to basically modify the implementation of a property or method. So I'm actually going to show you both. Actually, I'm not going to show you how to do a property. I'm going to show you how to do a computed property because a computed property is a little bit more complicated. So I'll leave that to you to figure out how to override a property for the circle class from a shape class. Like I said, it's a little bit easier to do just a regular stored property than it is to do a computed property, and I thought doing computed property is easier if I show you how to do it. So the computed property I want to override is the area, because if you notice when the getter it returns width times width, that is not accurate at all for a circle. So we need to modify this getter. And we also need to modify our setter because we're not going to actually update the width. I mean, we could do that, or we could just update the radius. We could try either one. Let's do either one. Maybe I will just update the width. Yeah, let's keep it consistent. So we'll update the width, okay? And then the next one I want to modify or change the implementation of is this wonderful method to calculate parameter, because this 4 times width is not how you calculate the parameter of a circle at all. So we gotta fix that one too. Alright, so I'm gonna go ahead and copy this. And the reason why I'm just copying this straight out is because when you override a property, you have to state both the name here and the property type that you're overriding, because the compiler has to check that your override matches the superclass property of that same name and of type. So it wants to make sure that, hey, you're updating this computed property. I want to make sure that what you're updating is accurate and that's actually contained in the superclass. So the shape is considered a superclass. It's also considered a base class. Same thing, okay? So let's go ahead and do that. So how do we do that? Well, we just type the override keyword, simple enough. Then we do var area, do cg float, and we do our override. So we do our getter. Oh, got some errors here. So it's giving us some errors here. So actually what I'm going to do is I'm going to go ahead and copy the information here so that it doesn't completely freak out when I'm doing this. Because we already know, so for a computed property, you have to update both the getter and the setter. We can't just do one or the other, okay? So I just copied the getter and setter from above, and then what I could do is I could just do the edits right here. So in order to calculate the area, it is pi times the radius squared. So we're going to do cg float, and we do m underscore 2 pi. And the reason why I do that, why I convert m2 pi into a float, is if you hold down the option key, scroll over m2 pi, and you see the m2 pi is a double. Yeah, so if you try to times a double by floats, the compiler will completely freak out on you. Okay, so that's why I converted it. And unfortunately, with square roots, there's not anything I believe that exists to do this, so I'm just going to do parentheses radius times radius to do the radius squared. Okay, it will work out in the end, right? So for width, what we have to do is we have to do some math. So basically what I do is I have to take out radius. So basically what this is, the radius is actually radius caret. Where's the caret? I don't see the caret. Sorry, I'm trying to find the caret. Okay, there it is. Oh, so it's R2. So basically it's pi times radius squared. So I'm going to pull out radius to do that math. So basically we're going to do square root. You didn't think you'd be doing math, did you? Well, you are. Alright, so square root, new value, because we're bringing, new width. So that's the name that we created. Divided by CG float, or pi, so we have to convert pi, close parentheses, and then what we have to do is we have to times this by 2 for the width, or the diameter. Alright, so there we go. We will update the width as well. Yeah! Okay. So the next thing I actually want to override is also a method. Because I mentioned above, we have our parameter method right here, which this calculation does not apply to circles. So we need to update that as well. So let's go ahead and do that. Again, we just used override keyword for our methods. We do function, and hey, look, it figures out, hey, it knows that we have a method called calculate parameter. Okay, so now it's asking us for the code to change our implementation for it. So let's go ahead and do that. And how do we calculate parameter? Well, it's 2 times pi times radius. So we do CG float into pi times the radius. Okay. Alrighty. So let's go ahead and pause right there. I will add some custom methods to this, but let's make sure, let's kind of have fun with our circle and see what its information, or what we can do with it so far. So we got red circle equals circle. Oh my gosh, there's our custom subclass, little subclass. If you notice, this setup here is exactly like our shape. Like this setup here is exactly the same format you would see for if I did like red square with shape. See, exactly the same. So it inherits everything that shape does from the superclass. So let's go ahead and fill this information out. Do red circle, and we do width. I'm going to change the width to 200 because I think 200 is cool. And let's go ahead and create a color, red color. I can't have a red circle without a red color. Alright, so let's take a quick peek at our info here. And sure enough, here's our information that we brought into it. Okay, so there we go. And let's go ahead and see what red circle's, I don't know what its radius is. It's 100. So that's absolutely accurate because our width, or our diameter, is 200. So half of that is 100. So that's right. Let's find out what red circle's parameter is. So calculate parameter. And there we go. It is 127. A bunch of information behind it. And you know, if you do this math, if we look at a calculate parameter of here, it would actually have been 400, which is not correct at all for a circle. Actually, no. It'd be 200 times 4, so it'd be 800. So as you see, this override that we did actually does work. All right. So we know that our updated, overridden, oh, I didn't do area. Let's check out area. Red circle area. Oh, we got, yeah, that's a lot. And let's say if we set it to something else. Let's say area equals, let's do 400. And let's check out red circles width. It should be different now. Yep, it's 50. Because above our area was 200. So we know that our information works. Okay, so I'm actually going to delete this because I do want to keep the 200 width because it shows a really nice big circle. All right, which brings me on to basically what I want to do is I want a preview of our circle like we did here. Now the thing is when I did this preview of this blue square, I had to first of all tell it, hey, I want you to be an SK shape node, I want you to be a rectangle, I want it to be the blue square structure here, I had all this information that I had to write out, and then I wanted to fill the color, and I want it to be blue. Now that's a lot of typing, and I don't want to do it for my circle. So what I'm going to do is I'm actually going to extend my superclass. So all the information I got from my superclass, I want to actually extend this subclass with some custom methods so I don't have to do all that typing I did above. So the first method I'm actually going to create is one that creates the shape. So we do create shape, and it's going to return an SK shape node like above, where we had the blue square. We use SK shape node, so I'm actually going to do that. And what I want to return is SK shape node, and do circle of radius, and I'm going to say, hey, self and radius, because I already have the radius, right? So that I'm telling it to do that. So instead of me having to type out nonsense like I did up here, all I have to do is call this wonderful method on the instance. And the next thing I want to do is do the add fill color. And this is going to return an NS color. And the return self color. Okay, so let's try out our new custom methods for our subclass. So let's go and do var red circle display, and this is going to be equal to red circle, create shape, and bam, there we go. Let's take a quick peek at it. Oh, you can't really see it, but basically what it is we see this light outline of our circle, which is exactly what I want. And then the next thing I want to do is I want to fill in this circle. So I'm going to say red circle, fill color equals red circle display, and I'm going to do the add fill, oops. Oh, I'm doing it the wrong way, sorry. Just realized I was doing it wrong. Display fill color equals circle, and then add fill color. Let's take a quick peek, and there we go. So we see our red circle now is filled with the color from red color. All right, so that is it. So basically in this video I showed you subclasses. So it's basically the act of basing one new class off of an existing class, which completely shows basically a fundamental behavior that makes classes way different from structures or their types in Swift. I showed you the basic syntax of a subclass. I also introduced lazy stored properties. It's basically telling the compiler, hey, wait until this class is initialized before you actually do any calculations. I showed you how to override a computed property as well as a method that the subclass inherited from the superclass. And then I showed you how to extend the subclass using custom methods. So we did everything we did above, but it's all nice and tidy now, not so horrible looking. So if you want to continue on, I definitely recommend you try out to, you can update or actually try to override just a standard property. I definitely recommend you try doing that. So go up here from the shape class and choose a property to overwrite. You know, you could overwrite maybe a name or maybe X or Y. I don't know. Maybe point. Maybe you can override another computer property, or you can make a new property and override it. Another thing you could do is you can actually create another class for another shape. So let's take, I don't know, an ellipse, which could be slightly different from a square. It is actually. I believe an ellipse is a part of SK shape node. So if you hold down SK shape node, we could take a quick peek at the reference, and I believe ellipse is on here. So Control find or Command find. Yep, there we go. So we have an ellipse here that you can create. So try creating another shape or another class, but call this class ellipse. You could do something like that. So you do ellipse. And I believe the math would be different too. Yeah, it is different. Like you would definitely have to override the calculate parameter method, and also the area method you would also have to update too, or the property, this computer property, you would also have to update. I don't think you would need the radius at all, but you might need to add maybe a couple more variables to do the math for the area and the parameter. So there you go. So there's some, you know, extra to-dos that you can try, but definitely play around with it. Really, the best way to get familiar with classes and to get familiar with inheritance especially, and modifying this behavior is to play around with it. I mean, yeah, that's the only way to really do it, okay? Alright, so if this video has helped you at all, you know, definitely hit the like button. You know, if you want, again, to be notified when I upload videos, subscribe. Alright, friends, code on.